segment 8 tumor by positive staining technique to identify the lesion of the segment 8 ventral side. The ICG solution is injected into the P8 ventral branch. This image is obtained by the other imaging system, so the imaging quality is high definition, not 4K. But anyway, this lesion is clearly visualized and this lesion is removed. I prefer the ground flushing method. And this is led after the removal of the segment 8 ventral lesion. And this patient had another tumor identified by ICG fluorescence imaging due to the preoperative injection of ICG. And after the inflow occlusion to the right lateral septum, ICG is injected then intravenously to identify the demarcation of the right posterior center by negative staining technique. And with the use of fluorescence imaging, this extended right dorsal right lateral septorectomy is completed like this. But recurrence occurred after this surgery, and this patient had 3 recurrent tumors surrounding the right hepatic duct, as you can see in this figure. So I designed to remove these 3 recurrent tumor by extended resection of the remnant right liver. The key point of this surgery is how to identify the biliary structures of the hepatic hyla during surgery. So for this purpose, luminal lens worked very well. Let's see the actual image. So even for the dissection of the adhesion around the hepatic hyla, luminal lens fluorescence imaging is very effective to identify the exact location of the bile duct or the hepatoduodenal ligament, enabling surgeons to dissect adhesions safely without injury of the hepatic duct. This is the common bile duct. Then after the fluorescence imaging is also used, this is the tumor fluorescence signals like this. And this is the common bile duct. The left hepatic duct will be there, around there. This will be the stump of the cystic duct. So thanks to the fluorescence imaging, we can divide a small connection between the hepatic duct and the tumor like this. And fluorescence imaging again. This is the tumor fluorescence signals, and the surgeon can set the transaction point on the right hepatic root of the right hepatic duct like this. And sometimes the grayscale imaging is very useful to visualize the biliary actual anatomy. And this is the parallelized mode. So this is the tumor fluorescence signals, right hepatic duct, left hepatic duct. So with the use of the fluorescence imaging, we can insert the right hepatic duct directly and the right hepatic duct is divided. This is the tumor fluorescence signals, very strong. And the right hepatic duct is removed, divided, sorry. This is the tumor. And there are other fluorescence signals emitted from the remaining 2 tumors. And no fluorescence signals from the left liver to be observed. Then the hepatic parenchyma is transected to identify the middle hepatic vein to be dissected. And the middle hepatic vein is ligated. This is the tumor. Then divided. And this is the last attachment between the specimen side and the hepatic hyla. This component includes the small hepatic duct draining the caudate wall. And this attachment, which is divided with the use of fluorescence imaging. And finally, the right hepatic vein is divided, and then the extended right hepatectomy is completed. After the removal of the liver, the fluorescence imaging is used again to confirm the preservation of the left hepatic duct draining into the common bile duct. No bile leaks identified by fluorescence imaging. And at this time point, I also additionally inject ICG for the confirmation of the blood flows to the remnant liver. Here we can see the proper hepatic artery, left and right hepatic arteries. And then here we can see the very small blood flows to the hepatic duct.